Today we're going to be working on some word problems that deal with division, but these problems are going to have more than one operation. So they're either going to have multiplying and dividing, adding and dividing, or subtracting and dividing. So I'm going to give you an example of each type of problem in our video, and then you'll be doing some different problems on your own afterwards. So here's our first problem that we're going to look at today. Let me get in there. All right. So I have Miranda has 180 beads for making jewelry. She buys 240 more beads. She wants to store the beads in a case with 6 sections. She wants to put the same number of beads in each section. How many beads should Miranda put in each section? Okay, so I'm going to kind of follow the steps that we worked on last year in school when we went through our word problems. All right, the first thing that we're going to do is we're going to underline the question. Okay, so I'm going to find the question. What is this problem asking me to find? So I'm going to find my question. Here it is. How many beads should Miranda put in each section? How many is going to fit in each section if she has 6 sections to fill? Then I'm going to circle any important numbers or information in my problem. So I know that she has 180 beads already. Then she buys 240 more beads, and she wants to store the beads in a case with 6 sections. So those are the things I know I'm going to need to help me solve the problem. And she wants to put the same number of beads in each section. So that makes me know I'm talking about equal groups. I want some equal groups. All right, now I'm going to box out some clue words. Box out any clue words I see that might help me know what I'm going to do with my numbers. All right, so I'm going to take a look at some things. So I know that she starts with 180 beads, and then she buys some more. Okay, so she's buying some more. So that makes me think that I'm going to be adding. Okay, when I buy some more, I might be adding. She wants to put them in a case with 6 sections, and she wants the same number in each section, same number in each section. Okay, each tells me I'm multiplying or dividing, and I'm taking these big beads and I'm putting them into smaller amounts, so I know I'm going to be dividing. I'm getting the same number into each section I'm going to divide. So that's what my clue words tell me. So the next thing I'm going to do is I'm going to make a plan. So I'm thinking I'm going to have to figure out how many beads does she have altogether. She has this many beads, 180, and then she gets 240 more. So I'm going to add. Then I need to divide those by how many sections she has to put them in. So my plan is I'm going to add my beads, and then I'm going to divide it by the number of sections. The last thing I'm going to do, I'm going to write my equation, and then I'm going to solve it. So my equation would be 180 plus 240. Those are my beads all together, and I'm going to divide that after I add it. I'm going to divide it by 6. That's my equation. All right, so let's go ahead and solve that problem. 180 plus 240. That would give me 420 beads divided by 6. Okay. Oh, that's nice. That's a nice one that I can just use some of my basic facts to help me solve this one. 420 divided by 6. 42 divided by 6 is 7. So 420 will give me 70. So the answer to this problem, how many beads should Miranda put in each section? 70 beads in each section. Okay? 70 beads in each section. All right, let's take a look at another example. Here's our second example. All 203 students at Polk School eat lunch at the same time. One day, 19 students were absent. If 8 students sit at each table in the lunchroom, how many tables were used that day at lunch? Okay, let me read it. All 203 students at Polk School eat lunch at the same time. One day, 19 students were absent. If 8 students sit at each table in the lunchroom, how many tables were used that day at lunch? Let's see. So first thing I'm going to do is I'm going to underline my question. How many tables? I'm looking to see how many tables were used that day at lunch. Okay, so I'm looking for the number of tables that are going to be used by the students eating lunch. Okay, the information that I have, let's see if I can circle some important information. Well, I know that there's 203 students. They're all eating lunch together, and one day, 19 of them were absent. So if they're absent, they weren't there, right? And then I know that 8 students sit at each table. So 8 students at each table. All right, so those are my important things. I'm going to look for my clue words to help me know what I'm going to do with these numbers, okay? So again, there's 203 students. One day, 19 were absent. So you're absent and you're not there. So if they're not there, I probably would be taking those kids away, not including them in my count. Okay, so that's making me think that I might need to subtract. If 8 students sit at each table, okay, I have this word each. Each usually tells me if I'm going to multiply or if I'm going to divide. If I'm multiplying, I'm getting a bigger number. If I'm dividing, I'm getting a smaller number. All right, I have 203 students. 8 of them are sitting at the table. I know we have less tables than students, so I'm going to be dividing. 8 students sit at each table in the lunchroom. How many tables were used? I want to know how many tables, so I'm going to divide. So I'm going to come up with my plan. My plan is I'm going to subtract 203 minus 19 to find out how many kids were there that day. And then I'm going to divide it by 8 so I can see how many kids would sit at each table. All right, so let's go ahead and write out my equation. 203 students minus the 19 that were absent. And then I'm going to divide that answer by the 8 students at each table. So 203 minus 19 gives me 184 students were there that day. And I'm going to divide that by 8. Divide that by 8. All right, so I'm going to have to write that one out. 184 divided by 8. Let's see, 18 divided by 8 is 2. 16. Let's see, 8 times 3 is 24. And I don't have any kids left. So it looks like I'm going to need 23 tables. 23 tables for all of the students that were there that day to sit at the lunchroom. Okay, and we're going to do one more example problem. Here's our last problem for today. Jose uses 3 flowers for each corsage that he makes. A corsage is a flower that a girl would put on her wrist or on her dress if she's going somewhere fancy, okay? He has orders for 18 corsages, each from 2 different stores. How many flowers will he need? So let's go back and take a look at this question again. Jose uses 3 flowers for each corsage that he makes. He has orders for 18 corsages from 2 different stores. How many flowers will he need? All right, so let's see. I know that he needs 3 flowers for each corsage. Oh, sorry, let's underline our question. How many flowers is he going to need to make all these corsages? 3 flowers for each corsage. He has orders for 18 corsages each from 2 different stores. So one store ordered 18 and then another store ordered 18. And then each of those corsages is going to need 3 flowers. All right, so let's see. I have a lot of the word each in here, a lot. Each corsage needs 3. We have 18 each from 2 different stores. So how many flowers will he need? So I'm going to make my plan. And I'm going to say, well, I have one store ordered 18 and another store ordered 18. So I'm going to have to do 2 times 18. 2 stores each ordered 18 corsages. So that's multiplying. Each of these is going to need 3 flowers. each of these is going to need 3 flowers. So it looks like after I find that answer, I'm also going to have to multiply to find out how many flowers he needs. He needs more flowers than he has corsages because each corsage has 3 flowers. So first thing I'm going to do is 2 times 18, which gives me 36, and 36 times 3. I can write that out like this. Looks like I have 108. He is going to need 108 flowers for the corsages that he is going to make. All right, so today you're going to go through, do some word problems. They're going to have more than one operation, so you might have to add or subtract or multiply before you do any dividing, or like this problem, we just had some multiplying. Think about what the words mean and what order you're going to need to do those in.